Good morning, dear students. Welcome back to physics class. Today I introduce new chapter which is motion in a straight line. The topic is elementary concepts of differentiation and integration for describing motion, part A. The subtopics are A. Introduction to the concept motion, and B. Uniform and non-uniform motion. It is well understandable thing that all of you are familiar with the common useful process motion. Because of you have learned some about it in previous year's class and experienced it before and still be experienced by it. But now I try to remind you the concept by asking the common question, what is motion? Can you say about it? In physics, motion is the phenomenon in which an object changes its position over time. Examples are flying kite, moving train, Earth's rotations, etc. Then, what is about rectilinear motion? It is one type of motion of an object along a straight line. It is also called linear motion or straight line motion. Actually, our chapter deals with the rectilinear motion of a body. When anybody can define the state motion, he or she should be enabled to define the state rest. What is rest? If an object does not change its position with respect to its surroundings with time, then it is said to be in the state of rest. In physics, sometimes it uses the concept point mass object when it describes the motion graphically. What is point mass object? An object can be considered as a point mass object if the distance traveled by it in motion is very large in comparison to its dimensions. In general, motion along a straight line is described using only x-axis of the coordinate system. As shown in figure, two cars are considered to move in opposite directions. The first car, which is blue in color, moves along the positive x direction, and second one, which is in orange color, moves along the negative x direction. Suppose two cars start their motion from the marked point 0 on the x-axis. So 0 is to be considered as the origin or starting point of the motion. When 0 is considered as the origin, it is also represented by O. Here I attach a coordinate system which consists of two axes, x-axis and y-axis, with the moving objects. This kind of coordinate system with time frame is called frame of reference. Motion of an object is always with respect to some frame of reference. You should notice this point that objects changing their positions with the time with respect to the frame of reference are in motion, while those which do not change their position are at rest. How can you give the justification to these points? Consider a moving car and imagine a coordinate system or frame of reference. For the simplicity, it may be the road or the ground. With respect to the frame of reference, outside the car, it appears moving. But with respect to the frame of reference inside the car, which may be the car's floor or the body panel, the car appears stationary. The figure shows a coordinate system which consists of three axes, x, y and z axes. Let O be the origin or starting point of an object and P be its position after the time t. As I have told earlier, motion means change in position of a body over time. So, time is important factor in coordinate system. So, time is called time frame. As shown in figure, the object can change its position with respect to the point O. So, the point O is called reference point. Motion can be broadly classified into three types. They are one-dimensional motion, two-dimensional motion and three-dimensional motion. First one-dimensional motion. What is one-dimensional motion? It is the motion along a straight line which specifies direction. We use one coordinate axis. It may be x-axis or y-axis or z-axis to describe this kind of motion. Examples: a car moving along a straight road, motion of a train on its straight track, etc. Second one is two-dimensional motion. It is the motion of an object along a plane. That is, we use two axes, x and y axis or y and z axis or x and z axis to describe the motion of the object. If a straight moving car changes its direction as shown in figure, one-dimensional motion is turned into two-dimensional motion. Other examples are a gymnast on a balance beam, clown shot out of a cannon, etc. And third one is three-dimensional motion. It is a kind of motion of an object in space. Here we use three axes all together at a time to describe the motion of the object. Examples are motion of a kite, motion of butterfly, etc. You have to note these points. Rectilinear motion need not be always one-dimensional motion necessarily, but it is always possible that rectilinear motion be treated as one-dimensional. How can justify these statements? For this, I consider a car which is moving along x-axis of a coordinate system consists of two axes, x and y axis. It is not a matter whatever the direction of the car, it may be either positive or negative. We say that the car is in one-dimensional motion because it is along x-axis. Suppose I rotate the coordinate system to a little extent. Then the car lies on a plane, that is xy plane. So the car's motion comes to two-dimensional. Actually, the car is in rectilinear motion. But now the car is in the plane, which represents two-dimensional motion. This is the justifications of the previous statements. On next you are going to study about what are uniform and non-uniform motion. At first you have to recollect how to differentiate between first one distance and displacement and second one speed and velocity. What are distance and displacement? First for distance. Distance is change in position of an object without specified direction. Thus, it is a scalar quantity as this quantity has only magnitude but not direction. It is the measure of total length of path travelled by an object, but displacement is change in position of an object with a specified direction, so it is a vector quantity as it has both magnitude and direction. That is, displacement means shortest distance between starting point and finishing point of an object. Change in position is usually denoted by delta x, which is x2 minus x1, and change in time is denoted by delta t, which is t2 minus t1. Suppose a person goes from home whose position is represented by O to school whose position is represented by x2 and comes back from the school to park whose position is represented by x1 as shown in figure. Then what should be the path length? Path length will be equal to the distance between home and school plus the distance between school and park. Then it will be equal to OX2 plus S2X1, which is equal to 80 plus 60 is equal to 140. This is always positive quantity. The sign, which may be either positive or negative, indicates its direction. You have to remember that magnitude of displacement may or may not be equal to path length, and the magnitude of displacement will never be greater than the path length. And for a non-zero path length, the displacement can become to be zero, because in this case the object returns to the original position or starting position where the starting point is in coincidence with the finishing point. And also you remember that the distance or the path length will never become to zero. Then what are speed and velocity? These things you studied in 9th class. Speed means rate of change of distance. Distance traveled by body divided by the time. And velocity means rate of change of displacement. It is the total displacement traveled by a body divided by the time taken. Speed and velocity, both of them are having same units. In SI system, their units are meter per second. Speed is a scalar quantity, but velocity is a vector quantity. Rectilinear motion or linear motion can be of two types. First one is uniform rectilinear motion and second one is non-uniform rectilinear motion. What do you mean by uniform rectilinear motion? A body is said to be in a uniform rectilinear motion if it travels in a straight line covering equal distances in equal interval of time. It should be having a constant velocity. But for a body which is in non-uniform motion, travels in a straight line covering unequal distances in equal interval of time. That is, the body travels with non-constant velocity or variable velocity. An example for uniform motion is if a car travels at a speed of 60 km per hour, then it will cover a distance of 1 km equally in equal interval of time, which is 1 minute each. In this case, equal distances covered by the car in equal interval of time, it is in uniform motion. And the example for non-uniform motion is that a boy kicking a football. It might cover 4 meters in the first attempt, 6 meters in the second attempt, and in third attempt it will be 9 meters and so on. Here, unequal distances covered by the ball in equal interval of time, then it is in non-uniform motion. Dear students, today's homework questions are given in this slide. Kindly please, you have to study these question answers. I request all of you, please you watch some videos related to motion in 9th grade class level which I uploaded earlier in our channel. It will be helpful for you. Okay, thank you. Have a nice day.